All right, welcome to a brand new semester, everyone. We are going to begin talking about right triangles. And one of the most common things we've probably seen about right triangles is this little deal right over here. Usually it's a squared plus b squared equals c squared. You've seen that before. Or you could just say c squared equals a squared plus b squared. Either way, this is what we call the Pythagorean theorem. In a right triangle, the square of the length of the hypotenuse, c squared, if we square this, it's going to equal a squared plus b squared, the sides of the two legs squared. Every right triangle has two legs and a hypotenuse. Right triangle. 1, 2, and right over here. So leg, leg, and the hypotenuse. Which means the hypotenuse has to be the biggest side. It's always opposite the right angle. The right angle is always the biggest angle in a right triangle, and the hypotenuse is the longest side. So you can find the missing side if you know the length of one of the sides, or two of the sides, I should say. If you know the length of two of the sides of a right triangle, you can find the length of the third side just by doing some simple algebra. So, quick example, let's say that A is 5 and B is 6. What would C squared equal? So A is 5, this is a short side. Nice little thing to do is make A your short leg, B your middle leg, and C the long leg. C has to be the long leg because it's the hypotenuse. And that's where it goes in the Pythagorean theorem. So 5 squared plus 6 squared will equal the hypotenuse squared. And then you just solve that out. Anytime you have to deal with squaring, and eventually we're going to need to square root a lot of these answers, we're going to need the calculator. So I have Desmos on the side right over here, and I'm going to go back and forth to Desmos and using the calculator. Of course, you got the Casio calculator, so you can use those too. So 5 squared, 5 squared. I happen to know that's 25. And 6 squared would be 36. In case you don't know, just plug it into the calculator. If you have a calculator to use, there's no penalty in using it. So then we just solve it out. 25 plus 36 is 61. So c squared equals 61. And c, we're not looking for c squared, we're looking for c's, which means we need to, if we square c to get 61, we've got to do the opposite of that. The opposite of squaring is actually finding the square root. So the square root of 61, plug that in the calculator. Radical 61, we call the square root sign the radical sign. This gives us this big number, 7.81, blah, 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 blah. I'm going to round to the nearest tenth. So I'm just going to go C about approximately 7.8. Now, most of our answers, we would need to round to the nearest tenth or nearest hundredth, depending on what the question is. I'm going to do another example real quick. I'll do another example later on. So that example had a decimal as our answer. And a lot of our Pythagorean theorems and a lot of our right triangles will have a lot of decimals. However, you do have some Pythagorean theorem and some right triangles that just have integers. This is where this little deal comes in. Right over here. If I actually use these numbers, I can get a right triangle without using any decimals whatsoever. These are called Pythagorean triples. A series of 3 integers that can create a right triangle, period. 3 positive integers, I should say, because you can't really use negative integers to do anything with measurement. So if you go 3 squared plus 4 squared equals 5 squared, the right triangle. Not quite a right triangle. Try that again. Much better. This will be 3. This will be 4. That's 5. And then you just do the math right over here. 3 squared, 3 times 3, 9. 4 squared, 4 times 2, 4 times 4 is 16. 5 squared would be 25. And if you do that math, 9 plus 16 is in fact 25. 25 equals 25. So yeah, that checks out. 3, 4, and 5 is one of the most common Pythagorean triples. And even if you double that, just get 6, 8, or 10, or 9, 12, or 15 when you triple that, those are also Pythagorean triples based on the 3, 4, 5. You don't need to know all of them, you just need to know the base one, the most simplest one. 3, 4, and 5 is a common one. Another common one, 5, 12, and 13. 5 squared plus 12 squared equals 13 squared. 8, 15, and 17, and 7, 24, 25 are also common as well. These are the 4 most common Pythagorean triples that you'll see. You may need to recognize one of these 4 on a quiz or on a test. Name a Pythagorean triple. 3, 4, 5. Boom. Simple as that. So again, like in the notes right over here, the most common Pythagorean triples are in bold. Other triples are a result of either multiplying it or taking it into, just multiplying it, because you can't go any lower than that. So we talked about the Pythagorean theorem. What about this whole idea of the converse of the Pythagorean theorem? If you remember converse, that's when we take a statement, a conditional statement, and reverse it. So the Pythagorean theorem, if you go back right over here, in a right triangle, the square of the length of the hypotenuse is equal to the square of the squares of the length. So that means if you have a right triangle, comma, then a squared plus b squared equals c squared. Now, if we take the converse of that, if a squared plus b squared equals c squared, then you have a right triangle. So in other words, we can test out if a triangle is a right triangle just simply by seeing if a squared plus b squared equals c squared. If it does, you have a right triangle. If it doesn't, guess what? You do not have a right triangle. So I'm just going to create a quick example right over here. I'm going to pick out 3 numbers. I'm going to pick out 3 random numbers. I'm going to go 14, 48, and 50. Actually, those are big numbers. I'm going to go smaller than that. Let's do 10, 11, and 12. Let's just do that. So we're going to test to see if this is a right triangle. Now, the side lengths of this triangle is 10, 11, and 12. Which is going to go into the long spot? Now, the longest side has to be the hypotenuse, c squared, which means the biggest number has to be the hypotenuse, 12. So 12 squared has to equal, if I can get this going, there we go. 12 squared has to equal the other 2 sides squared, 10 squared plus 11 squared. And I already have a feeling it's not going to work. Let's test it out. 12 squared, I'll just do the math right over here. 12 squared is 144. 10 squared, 10 times 10, 100. Plus 11 squared, which is 121, which would be something that's not going to work because 221 equals 114. It does not. So is this a right triangle? No, it's not. This is not a right triangle. It's a triangle, but it's not a right triangle. We can actually use the Pythagorean theorem to see what type of triangle it is. at the very least, to see if it's not a right triangle, is it an acute triangle or is it an obtuse triangle? The rule is with Pythagorean inequalities, the rule is this: if your c squared is smaller than your a squared and b squared put together, you have an acute triangle. If your c squared is bigger than your a squared plus b squared, then it is, let me zoom that out, obtuse. Again, if c squared is smaller than a squared plus b squared, you have an acute triangle. If c squared is bigger, then it is an obtuse triangle. So in the example up here, 144 was actually bigger or smaller. It was actually way smaller than 221. So that means this triangle is not a right triangle. It's an acute triangle. So these are the type of examples that you're going to need to work with Pythagorean theorems. Using the Pythagorean theorem to find a missing side, and then also using the Pythagorean theorem to test out if the triangle that's presented to you is a right triangle or not, and if not, is it an acute triangle or an obtuse triangle? Of course, if c squared equals a squared plus b squared, it is a right triangle. All right, so let's do these examples right over here on the second page, and we'll do all of them. We're going to find the value of x in each one of these problems, 1 through 6. And I'm going to break out the calculator because we are going to need the calculator to do some of these. What we're going to do is whenever we get an answer, we're going to round our answers to the nearest tenth. Round to nearest tenths. There's some examples, there are some examples where you're going to need to give an exact answer using radical forms of decimals, but we're going to get to that later. But for right now, we're going to round to the nearest tenth. Starting with number 1. I have a side right over here in this triangle of 81. I have a side of this triangle right over here of 108. We don't know what this side is right over here. That's the x. We need to find the value of x. We need to find what number would go in there. So this is simple. This is a right triangle. Opposite that right triangle is the hypotenuse. We are looking for the hypotenuse. That means the 2 legs squared, 81 squared, plus 108 squared will equal the hypotenuse squared. And these are going to be some big numbers, so let's get that calculator going right now. So 81 squared, 6,561, that's a huge number. 561 plus 108 squared, 11,664. Whenever you're squaring numbers, you're going to wind up dealing with some pretty big numbers. So when you're dealing with numbers that are going into the hundreds and the thousands and the tens of thousands, be very, very careful. If you copy in your numbers wrong, you're going to go wrong with your answer. So be very, very careful when you're dealing with some big numbers here. So 6,561 plus 11,664 gives me 18,225. 18,225. That's c squared. And I need to find the square root of that. Take the square root of that. 18,225. And we got a nice round number right over here, which is 135. So square root c equals 135, which makes this answer 135 units. So number 1 is 135. Number 2, this triangle right over here, let me clear out my calculator. I have this side at 4, different color. We'll use red. I already used that. We'll use pink. We have 4 right over here. We have 8 right over here. We're missing this right over here. But this time, the hypotenuse, we already have a number right over there. This time we're not looking for one of the hypotenuse. We're not looking for that. We're looking for one of the legs right over here. So that means 4 squared plus whatever x squared is equals 8 squared. So if you're finding the hypotenuse, you add up your two numbers, but this time, we've got to do a little algebra right over here because we can't solve for x. We want the x by itself. So what I'm going to do, I'm going to take this 4 squared and move it over to the other side of the equal sign. And if you remember from algebra, anytime you move anything over to the other side of the equal sign, it becomes a minus. So 8 squared minus 4 squared will equal x squared. So 8 squared is 64, 4 squared is 16, 64 minus 16 is 48. Yep. And just to be thorough, 8 squared 64, 4 squared 16. Yep. So 64 minus 16, and it's okay to double check your numbers with the calculator, even if it's something you think you should know with mental math. It's okay to double check in the calculator if you have a calculator with you. Square root of 48 is a decimal, and I'm going to round this to the nearest tenth. So this becomes about 6.928. The tenths place is this first decimal spot. Look at the side next to that, and that 2 is below the mark. So that means when I round this, this will become 6.9. You're going to need to make sure you're good on your rounding, because if you round wrong, you're going to get points taken off your quiz. So x about 6.9. There's your answer right there. Move on to number 3. 15, 20, here's the x. Where's the right angle? Here it is. It takes you to the hypotenuse, and we're looking for the hypotenuse this time. We have the two legs. 15 squared plus 20 squared equals x squared. And clear the calculator out so we can do this problem right over here. 15 squared, 225. 20 squared, that should be 400. Yep. 400, do it another line right over here. 400 plus 225, 625. Take the square root of 625, and we get, this should actually be an integer, 25. If it's an integer, then it's equal. If you wind up with a decimal, I use the little squiggly equal sign to show that it's an approximate answer. So x equals 25, so the answer here is 25. Move on to number 4. Go ahead and pause number 4 for a second. See if you can do this one. All right, so let's see if you got it right. Here's 6, here's 10, there's my x. I'm going to use a different color. I'm going to use, I'll just stick with black right over here. Right angles right over here takes me to the hypotenuse on the other side. You're always looking for the hypotenuse because your hypotenuse is your c squared. That's the one by itself. The hypotenuse, we are looking for that, which means 6 squared and 6 and 10 are the two legs. They go right there. And x squared. A lot of times when you go wrong with these questions, you're placing the hypotenuse in the wrong spot. Because this isn't 6 squared plus x squared equals 10 squared. It's 6 squared plus 10 squared equals x squared. A lot of mistakes happen right over here with the Pythagorean theorem, so watch out. Make sure you know which one's your hypotenuse so you can place it in the right spot in the Pythagorean theorem. So 6 squared is 36. 10 squared is 100. And that's an easy one to do, 136 when you add the two together. 100 plus 36, 36 plus So the square root of 136, going to wind up with a decimal this time, I think. Yep. About 11.6619. I'll write this down over here. 6619, dot, 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 keeps going. Here's your tenths place. The number next to that is a 6. 5 or more raise the score. 4 or below, leave it alone. So that means we're going to call this 11.7. Number 4. I'm going to quickly work 5 and 6 for you guys. $55 squared, x and 77 squared. Where are they going to go in the Pythagorean theorem? Put it together and see. So let's take a look if you got it right. X squared, 55, here's the right angle. The right angle will always point you towards where your hypotenuse is. If you even take that and you draw an arrow like this, it'll point you to where your hypotenuse is. In this case, the hypotenuse has a number in it. So that means that 77 squared is going to go on that other side of the equal sign by itself. X squared plus 55 squared is going to go right over here together. Those are the two legs. So 55 squared, well, actually, what I'm going to do first, I'm going to take this 55 squared, I'm going to move it over to the other side of the equal sign. And 77 squared minus 55 squared. And then we'll just put that together in the calculator. 77 squared, big number. 55 squared, another big number. And I'm just going to do everything in the calculator this time. 5929 minus 3025 gives me 2904. X squared equals 2904. We need the square root of that. $53.88877, blah, blah, blah. And we're going to round that to the nearest tenth, so approximately 53.88, which makes it 53.9. And then the last one, 48, 90, and x right over here. The right angle will point you towards where your hypotenuse is. And this time we're looking for the hypotenuse. 48 squared plus 90 squared equals x squared. And if you get really good with the calculator, you can do it all in one shot. But I'm gonna do this step by steps anyway. 48 squared, 2304, 90 squared. Bit of a trick right over here. 9 squared is 81. And then we're squaring the 0 as well, so that becomes 8100. Add the two numbers together. $10,404. So the square root of 10,404 is 102. Hey, what do you know? It's a Pythagorean triple. Anytime you have three numbers, three integers, no decimals, and they make a right triangle, you have a Pythagorean triple on your hands. Now, you don't need to know the bigger ones, like going into 48, 90, and 102. You don't need to know that. If I ask you to name a triple, all I want is one of these top four right over here. 3, 4, 5, 5, 12, 13, 8, 15, 17, and 17, 7, 24, and 25. All right. I'm going to skip the word problem right over here because I want to spend a little bit of time testing out these numbers to see if it's a right triangle, or if it's not a right triangle, is it acute or is it obtuse? So the three sides of this triangle are given to me as 90, 216, and 234. The hypotenuse has to be the longest side. So which side is the longest side? It's the side with the biggest number, 234. So 90 squared plus 216 squared has to equal 234 squared. So get the calculator out and test this out. 90 squared, 8100. These are going to be some big numbers, but we can still test it out. Plus 216 squared. I always forget to reset the line right over here. 46,656 equals 234 squared, which is 54,756. All right. So now I'm going to add the first two numbers, 8100, 8100 plus 46656 gives me 54,756, which is the same thing as what we have on the other number by itself. Much better. So does this number equal this number? Yes, it does. Which means this is a right triangle. All right. And then the last problem on this set for these notes is this one right over here. 1, 1, and radical 3. So which one is going to be the bigger number here? 1, 1, or the square root of 3? Well, let me put that in the calculator to see what it equals. The square root of 3 is about 1.7, which is bigger than 1 and bigger than 1. That means that number has to be the bigger number. So radical 3 squared equals 1 squared plus 1 squared. And it just so happens whenever you take a radical and you square it, radical 3, and I square that, we just get the radical, we just cancel out the radical. Anytime you square a radical, you cancel it, and the number just pops back out again. A little bit of a hint to help you guys when you get to algebra 2, something to remember. So radical 3 squared is just 3, and then we just go 1 squared, which is 1, and 1 squared again, which is, we already have that, so 1 plus 1, which means 2 equals 3. Does 2 equal 3? It never has, it never will. So is this a right triangle? No, it's not. It's not a right triangle. It has to be either acute or obtuse. Some questions will ask you, is this a right triangle? Yes or no, simple as that. And some questions will ask you, is this triangle acute, right, or obtuse? We just ruled out it's not right, which means it has to be either acute or obtuse. Which one is it? Remember, the difference is the c squared. If the c squared is bigger, it's obtuse. If c squared is smaller, then it's acute. Excuse me. So the c squared was radical 3 right over here, which was 3. So that's your c squared. Is it bigger or smaller than 2? 2 is, I should have put it the other way, but this case, the c squared is bigger. So c squared is bigger, which means this triangle is an obtuse triangle. So that is your rundown for the Pythagorean theorem, how to use it to solve for a missing side, how to test for if it's a right triangle or not, and how to test if it's an acute, obtuse, or right triangle.